J.R. Argand and Caspar Wessel are the two mathematicians who worked independently and came up with the idea to represent complex number geometrically. Argand's idea is very famous in showing complex numbers in a plane because it gives a visual and geometric representation of complex numbers using two real number axes, x and y. Argand plane or Argand diagrams are the terms used in mathematics to show respect to J.R. Argand. Let us learn about how to represent a complex number geometrically. It is really difficult to visualize numbers such as z is equal to x plus iy. That is why complex numbers are abstract. But using certain hints such as complex numbers are the ordered pair of two real numbers, Argand tried to visualize these numbers and try to represent it on a plane. As we know, these ordered pair represent a complex number where x is the real part of complex number and y is the imaginary part of complex number. Argand plane or Argand diagram is a coordinate system where the horizontal axis or the x-axis represents the real part of a complex number. That's why we can give the name to the x-axis as the real axis. And the vertical axis or the y-axis represents the imaginary part of the complex number. That's why we have a name for the y-axis as the imaginary axis. And distinct points on this plane represent distinct complex numbers. For example, z is equal to 3 plus 2i, a complex number, can be plotted on this plane. To plot any complex number or a point on this plane, we need two numbers, ordered pairs. So from the complex number 3 plus 2i, these ordered pair is 3 and 2. So our complex number or the point 3, 2 is 3 units on the x-axis and 2 units on the y-axis from the 0. And 0 is again represented by ordered pair 0, 0, in which x and y both are 0. So this is your point, and this point is your, for example, it is your z1, and z1 is the point 3, 2, in which 3 is the real part and 2 is the imaginary part. Let us give a general expression for this representation. Let us write your complex number as x plus iy, and these ordered pair xy represents a point P on the Argand plane. So your P is xy on the plane. And now if we try to a little bit explore the Argand plane and our complex numbers, then it becomes really fascinating. So if we try to write the conjugate, that is x minus iy, so our points are x and minus y. Let us plot the conjugate of this complex number. So the conjugate of this complex number, let's say the point is with the name p dash, that is x and minus y. The conjugate of a complex number behaves as the mirror image of the complex number. So if your complex number p, that is x plus iy, is something like this, then the mirror image will be exactly from the same distance from the x-axis. So x-axis or the real axis behaves as the mirror and the conjugate behaves as the mirror image. Your complex number can be anywhere on this plane and the mirror image would be just on the other side of the real axis or x-axis. Now if z is equal to x plus iy is a complex number plotted on the plane with the ordered pair pxy, then the distance from the origin to that point is the modulus of the complex number with the formula x square plus y square. So the modulus is x square plus y square, somewhat represented like this, you know it already. Now here x is the real part of z and y is the imaginary part of z. So if we square the real part of z and the imaginary part of z and add it, and the under root of this quantity gives the mod of z. This mod is the magnitude of the complex number and it is the distance of the complex number from the origin O. As I mentioned earlier, mod gives the magnitude of the complex number. And there is one more important thing that we need to know, is that what is the direction of the complex number. To do that, if a complex number is plotted with point P on the Argand plane, then the angle it makes with the x-axis, let this angle be theta, then the vertical side is the quantity y and the horizontal side is x. Then tan theta is equal to perpendicular by base. Here perpendicular is y and the base is x. Now theta is equal to tan inverse y by x, and this is called the argument of the complex number. So argument of a complex number is equal to theta, that is equal to tan inverse imaginary part of the complex number divided by the real part of the complex number. Let's take one example. So for the complex number z is equal to 2 plus 3i, find the magnitude and the argument. So magnitude is mod z, that is equal to under root x square plus y square, or the square of the real part and the square of the imaginary part. So that is 2 square plus 3 square, and the answer is under root 13. And for the argument, we have to find the theta, that is tan inverse the imaginary part of the complex number divided by the real part of the complex number, that is equal to tan inverse imaginary part of z is 3 and the real part of z is 2. So theta is equal to tan inverse 3 by 2 is your answer. And that is the argument of the complex number. With these concepts and examples, I just want to show you that how important and how interesting is the Argand plane and the Argand diagram. It is one important mathematical tool that can help us understand the nature of the complex numbers. But along with that, there are a list of benefits of Argand diagram. The first is that using Argand diagram, you can map or plot any complex number as vector or point. And as a vector, it has magnitude and direction. Your complex number also has magnitude, that is the mod of the complex number, and the direction, that is the argument of the complex number. You can also visualize the operations such as addition and subtraction that will come in the next part of the video. But actually, using the Argand diagram, you can show the addition and subtraction or multiplication of the complex numbers. Argand diagram is also the bridge between the algebra and the geometry of the complex numbers. And if you have plans to do higher studies in complex numbers, then also Argand diagram is kind of a gateway to understand the bigger theories and the more advanced theories in the subject. So Argand diagram turns abstract complex numbers into something visible and intuitive. It merges algebra with geometry and provides a powerful tool to understand, interpret, and apply complex numbers in a wide range of contexts. And let me give you two questions as your homework. Find the magnitude and argument of a minus 1 plus 3 iota and b minus under root 3 plus iota.